ABC is a horizontal uniform rod of length 40 cm and weight 50 Newton, hinged at A to a vertical wall. The end B is supported by a light string 50 cm long attached to a point C on the wall. By drawing a suitable triangle of force, find the tension T in the string and the reaction at the wall. Now, this is the diagram. Now, we're going to draw a free body diagram of this structure. Okay, there is no need to draw a free body diagram. What they want us to draw is a triangle of forces. Now, when you look at this structure, let me just draw it. You have the tension. This is the tension. This is the rod. Now, you have the weight of the rod here, which is 50 Newton. Now, this is the tension of this tiny string. Now, this one is the rod, and this object is at the middle. Now, there is a reaction here on this hinge, which will be pointing along this direction, R. Now, to draw the force triangle, look now, here is our A, here is B, here is C. Now, to draw a force triangle, the weight, which is 50 kg, is vertical. This is 50 Newton, the weight. Now, we have the reaction, which is R, in this direction. You now have the tension in this direction. Now, this is a triangle of force. So let me just call it triangle of force. So this is the triangle of force that we require. So now, this angle here, let me call it X. And the angle X is the same thing here. It's the same thing here, is X too. Is X because now you have this vertical line here and the string. This is the direction of the tension along the string. So if you see the here, which is X, is the same thing as here, which is X. Now, the length of the rod is 40 centimeter. And the length of the string is 50 centimeter. So, and you know that using Pythagoras theory, we know that this AC square plus AB square is equal to BC square. Now, we don't know AC, the length of AC. The length of AC square will now be BC square minus AB square. Now, we have BC square to be 50 square minus AB, which is the length of the rod, 40 square. Now you have 25,500 minus 1600. This will give us 900. So AC square is 900. So now this, taking the square root of both sides, you have AC equal to 30 centimeter. Now, having gotten AC to be 30 centimeter here, now using Sokotoa, sine Sokotoa. So sine of x angle will be, the sine is opposite all over hypothesis. So the opposite to angle x is 40. So you have 40 all over, the hypothesis is 50. So this is 4 all over 5 as sine x is 4 all over 5. Now cosine of x is adjacent all over hypothesis. Now adjacent to the angle x is 30 centimeter. So you have 30 centimeter all over the hypothesis, which is 50 centimeter. This is same thing as 3 all over 5. So cos x of angle is 3 all over 5. Now we have gotten that. Now with this triangle of forces, this angle here, this side here is equal to this side here. This is an isosceles triangle. Now this one is 50. Since here is equal to here, that means here is equal to x. So x here is x, here is x. So we have gotten this and this as x. So now here, this angle here will now be equal to, the sum of angle of a triangle is equal to 180. So the sum of angle of a triangle is equal to 180, which is equal to x plus, let me assume that this is y. Let me assume here is y. So x plus y is equal to 2x plus y. So y, so it implies that 2x plus y is equal to 180. Now adding minus 2x to both sides of the equation and add the two equations. This one will cancel out this. The left hand side will be y, which will be equal to 180 minus 2x. Now we have gotten the values of all the three angles in terms of x. So now let's solve using the sine rule. Using the sine rule for a triangle. Now we are asked to find theta, tension. We say find the tension and the reaction at the wall. So now you have the tension divided by sine of the angle it is opposite to. So now this tension is opposite to this angle, which is x. So sine x equal to, the other one is the reaction equal to sine of the angle that is opposite to. So this reaction is opposite to this angle x. now, which is equal to 50 all over sine of y, which is 180 minus 2x. Now, when you look at it now, the sine rule states that the force or the sine rule of a triangle, now it says that now this side, the length of this side, or the force along this line for a triangle of force, divide by the sine of the angle it is opposite to, is a constant. So now that is why this expression, the first term is equal to the second term equal to the third term. So now, for us to get our tension, we are going to use this and this. So since they are equal, you have t all over sine x equal to 50 all over sine 180 minus 2x. So multiply all through by sine x. You have t all over sine x times sine x equal to 50 sine x all over sine 180 minus 2x. Now this sine x will cancel this sine x. The left hand side is left with t, which is equal to 50 sine x divided by sine 180 minus 2x. So this is equal to 50 sine x all over, now expanding this sine x using the law of trigonometric laws, you have sine 180 cos 2x minus sine 2x cos 180. Now, for a triangle where here is very small, which is 0, and here is 1, here is 1, and here is 0, so cos 0 is equal to 1. Therefore, cos 180 is equal to minus 1. Sine 0 is equal to 0 all over 1, which is equal to 0, which implies that sine 180 is equal to 0. So now this tension, the expression for this tension now will now be reduced to this form: sine 50 times sine x. You have this sine 180 is 0, so the whole of this will be 0. You have minus sine 2x times minus 1, because cos 180 is minus 1. So this will now be 50 sine x divided by sine 2x. According to the law of trigonometric, sine 2x is same thing as 2 sine x cos x. So if sine s cancels sine x here, you are now left with 50 all over 2 cos x. So we now have 50 divided by 2 times this cos x is 3 over 5. So we have 3 divided by 5 as cos x. So this will give us 250 divided by 6. So this is 41.67 newton. That's our tension. Now from this expression, it shows that r all over sine x equal to tension all over sine x. Now it implies that r is equal to tension, which is equal to 41.67 newton. So let's find the angle. Let's find the angle of the angle of the reaction at the wall. So the angle of the reaction at the wall, which is this angle, or okay, to the wall, which is this angle, and it's same thing as x. So now I will now use sine. We know that sine x is the same thing as 4 all over 5. So x will now be arc sine 4 all over 5. Now let's use our calculator to solve this. We have arc sine 0.8. Now let's use our calculator to solve this. So 4 divided by 5. Now second function, second function of sine, which is 53.13. So 53.13 degree. So this is the answer. Thank you for watching. Have a nice day. Thank you for watching. Have a nice day. And if you like this video, please subscribe to my channel and hit the notification bell so that you'll be the first to receive this video when next I make new one. And also do well to help me to share the video. Thank you.